Hello everyone, thank you for your time. My name is Yogie Setiawan. I will present my research about sentiment summarization, learning evaluation, using LSTM or long short-term memory algorithm. In university, to improve the learning performance of a lecturer needed to determine the student learning experience. Learning evaluation is used as a lecturer self-reflection material to improve the learning service provided in the next lesson. Ganesha University of Education or UDIXA provides online questionnaire for each subject through the Academic Information System or SIAC, which students can fill out at the end of each semester. In the questionnaire, students share the experience while being taught by the lecturer. The large number of students taught by the lecturer in each course make the lecturer spend more time reading its evaluation. Evaluation containing review of criticism and suggestion make it difficult for lecturers to analyze. Lecturers need systems they can assist in conducting the learning evaluation analysis automatically. Here's the method. Here's the flowchart of the system. First, we label manual the dataset, then input the dataset into the system. After that, dataset will go into the pre-processing like cleaning, case folding, stopwords, theming, maxing, tokenization, and then result of the pre-processing will be the split data with ratio 8:2. And for the sentiment analysis, there are extra steps for resampling the data. Resampling the data is basically decreasing the amount of positive label as much as negative label, so the data will not bias. And then we create the LSTM model, and then after the model predict the sentiment, then we separating the sentiment, and then we summary each of sentiment. First for the positive sentiment, and then for the negative sentiment. Here's the detailed model of sentiment analysis. The activation function used is softmax, which is mathematically function that convert a number vector into the probability vector where each value proportional to the relative scale of the vector value. The result of the transformation into the probability value between 0 and 1 and suitable for multiclass. In addition, softmax is also the only activation function that is recommended for loss function categorical cross-trophy. The loss function use categorical cross-trophy, or also called the softmax loss, because one sample dataset can have several class or label, like our current situation. Here's the detailed LSTM model for the summarization. Just like the model for sentiment analysis, the activation function used in this model is softmax. The metrics used are accuracy, and the dropout is used. The difference is that the loss function used is sparse categorical cross-trophy, because each class or label is mutually exclusive, or each sample is owned by one or label. Sparse category cross-trophy returns the index category integer of the most suitable category. Here's the result of the sentiment analysis. After completing testing using testing data from 2,266 evaluation, it was found there were 118 evaluations that were predicted to have negative sentiment and match the actual label. And then there are 201 evaluations that are predicted to be negative and do not match for the actual neighbor, or we call false negative. And then 105 evaluations then predict to have positive sentiment and do not match the actual label, or we call false positive. And the last one is 188 evaluation. They are predicted to be positive and match the actual label. From the data table above, it can be seen the value of the precision, recall, accuracy, and F measure as follows. Here's the result of ROUGE testing for the summarization. In the negative evaluation, there are only 3 or 18 words that are the same between the summary prediction made by the system and the summary made by the language. The same words include the baik, dan, and mahasiswa, or in English means good and instant. The small ROUGE value was obtained because the summary rating technique was differing between the research and the dataset trained in the model and the summary made by the language. The differences in the summarization technique make the same number of words slightly smaller, resulting in a small ROUGE value. Conclusion: in testing the conversion matrix system, value means that the system is able to produce sentiment predictions that are in accordance with the training data. In ROUGE test, value means that system has not been able to generate summary prediction that match the expert summary of summary. The small ROUGE value was obtained are also caused by the fact that a number of epochs during the training of the summarization model is too small. The size of the dataset makes the training process take a long time in the study. In the study, the research with a limited resource and hardware were only able to do training with 50 epochs. We have a suggestion for the next researcher. We develop tokenizer has not been able to extract token from the training process. The tokens on each word become random and do not match what the previous model has learned. In the future research, the research who will create the training data will be better adjust the summary technique with the expert who become the reference so that the model can predict the choice of the same important sentence as the reference. And the expert should be able to test with the large number of the database. That's all my presentation. Thank you for your time. Bye bye.